All right, hello everybody. Tonight is the 4th of October at Dallas Personal Robotics Group Robot Builders Night Virtual. We are going to do the usual tonight and just bounce around the table. Maybe some questions, certainly a few things to demonstrate that we've been working on the last week. But without much fanfare, we'll dive in. We have a short queue ready. There's just the one item for anybody that's not noticed this or might be watching the video, and that is we have a fall competition coming up in November. And this will be a hybrid competition. I think, well, if anyone remotely wants to join, but there'll be a physical presence for sure. And that's all we got. Unless anyone else has something else they'd like to raise. Okie doke. So with that, we can dive right in. And we have the following queue ready to go. We have Ray, then Michael, then Doug, and then Scott, and then open mic. So, Mr. Ray, what you got? Good progress this week?
Yeah, pretty good progress. Things were getting kind of strange. Less and less stuff was working, and I was trying to fix it in software. I was, thinking, what was wrong. Anyway, I had two of the RoboClaw models. One was the 60 amp, and the other was the 30 amp. And the 30 amp would be good for this platform, and I wanted to put the 60 on another platform. And so I actually called the RoboClaw technical support to ask him, if anybody else was experiencing the same thing I was, certain flags that never got set and stuff like that. And one of the things he said was, have you checked your ground connection? And sure enough, when I swapped him out, I just kind of gave up on the one, and I was going to swap it out to see if it followed the 60 amp version. The ground screw wasn't as tight as it could be, and I think with all the vibration and bouncing around, it was. And that's the supply for everything. The RoboClaw has the BEC built into it, so the processor. Everything on the I2C bus was probably being affected by it. And so swapped out the parts, made sure the ground screw was very tight, and the problem has gone away. Things are working again. So that's kind of a relief. One of the things that I was playing around with real term and KS, I think it's just referred to as KST. I think some of the other people have played around with that. Doug, maybe.
Which one?
KST and real term. You can basically use KST to create files that you can print. You use real term to basically write into a file, and then you use that file to make graphs with, basically, or plot.
Oh yeah.
Points.
Yeah, all the time.
I think you've probably used it quite a bit.
Yeah, no
anyway,
problem.
This is the first time I played around with it.
Yeah.
And where is it?
You should say you have to configure your serial communication that you're sending to your computer so that it's in a CSV file or whatever file you want to put up.
Yep.
Yeah.
Anyway, so with the color sensor, it's real easy to find a cone if one is in the field of view when it's scanning with a servo from 0 to 180 degrees in front of the robot. What is more difficult is to realize that there is no cone in the field of view. So there's this kind of this background noise, the points here where it may see something orange, and I'm sure it's probably going to see some, orange in just sunlight. But, the peak the peak really stands out. You can have these little minor peaks, and I don't want to interpret that as being the cone, because that would be incorrect if there was no cone in front of the thing where it's scanned. So I've been working on ways to detect no cone, which is a little more difficult. So I tried like comparing the peak value to the average value, and that does not work. You can have little peaks where it is, and I was looking for a certain ratio of peak to average, and I arbitrarily chose 2. And that, if there is a cone there, it's going to be a lot more than 2, because here's one with a reading of like 120 versus the baseline, maybe, I don't know, somewhere maybe 30 or less for an average. So that's fairly easy to detect. But when there is no cone, I've got to tell it to, rotate the platform 180 degrees and scan again, because the cone is probably behind the platform. Anyway, so I think what I'm going to try next is like binning the numbers, like to say, okay, I want everything that's basically count all the points that are 30% of the peak value, and to try to find out where that, where the, let's see, what would it be, where the minor peak is, and then look around it and see if that looks like a peak from when you'd scan when you had a cone in front of you or in front of the platform. So I'm going to try that approach next, because just comparing it to the peak to the average, I can still get, peaks kind of in the noise that are above 2, and, where the ratio is greater than 2. So anyway, 3D printed some parts to kind of clean up the platform, and that's about it.
Right.
Yeah.
What I would consider, and I don't think this would be the whole algorithm, you'd probably have to manipulate it more. Can you go back to your graph again?
Oh, yeah, sure.
What I would suggest as part of your algorithm is using the differential between points. Okay, so that would, if you look at it, between the 2 points you got around 10, no, I guess it's 5 degrees, they would be very small. In fact,
Yeah.
if you've got this file, you could just easily just add a column for differential. And
Yeah.
what you would see, I think, is somewhere between 90 degrees, all of a sudden you'd get a big step up there, and you'd get another, just because of the way the data appears on this, you get a big data, and then you'd
Right.
start getting negative peaks. You can either use the absolute value or just let it be negative, and you can see it going back down. So that would give you an indication of signal. And like I say, it might not, I'd still think, the problem with derivative is you're not going to necessarily, you're going to see the difference between the 2 adjacent reads.
Right.
All right. So, you have to, I don't think it by itself will be a foolproof algorithm, but I think it might add a lot of information to what you're doing.
Okay. Yeah, I can look at that.
Yeah.
Yeah, I was trying to find, the other thing I thought about doing is finding like, the very highest peak, and then the second highest and third highest and fourth highest, and then looking around those to say, okay, is, basically somehow to compare it. And I still think the binning approach is going to work the best, because I don't think standard deviation is going to work, or any of those, to tell me, basically where the top of the floor is. There could be little minor peaks in there just from scanning the background. It's outside. There's probably some orange in
Well, that
God knows
usually
what,
that's
brown grass, you name it. There's, sunlight, just plain sunlight, I'm sure has plenty of orange in it. But so yeah, the scanning with the cone in front, not an issue. It'll find it every time. But I also need an indication that there's no cone in front when I scan, so that I can turn the platform around 180 degrees and scan again to see if it was, if I basically passed the cone or got in front of the cone.
Yeah.
So it wasn't in the field of view of the sensor when it's scanned 180 degrees on the servo.
The other thing I think you have to be aware of and figure out how to handle, because is what happens if it shows you 2 or 3 cones. I know you shouldn't see that, but life is like that.
Oh yeah, yeah, yeah. That's what I was talking about. Kind of like the looking for the second highest or the third highest peak. What are around those, and is it enough of a ratio to indicate that there's a cone, or it behaves as though there's a cone in front of it, like this does with the big peak or the big change in values, because it kind of goes from 30 up to I think 120 and then back down pretty quick. So, and at 20 feet, I may just have 3 readings, at 10 feet, I may have 4 or 5 readings. But
you're going to have more, because I'm going to be wearing orange bell bottoms.
Oh yeah, ooh man, we may have to get you a long house coat or something there.
Unfortunately, I won't actually be able to make it. We've got a tournament that day.
Oh man.
Yeah.
Well, Kareem, I'm going to have to take your lead and wear my orange cone shoes.
There you go.
There you go.
They look like elf shoes, except they have orange cones on the top. So wherever I walk, there are the cones.
Wasn't there an orange outbuilding of one of the neighbors too?
Yeah, his roof.
I went after that. So
That's what I was thinking of when I mentioned you might see 2 things.
Yep.
We're probably not going to have the same course, but there's definitely things in the environment. There's the dreaded pink flamingo, which I'm sure is going to be out there somewhere.
Yeah.
So,
yeah, but that's going to happen with, well, okay, maybe it won't happen with Doug's approach, where you're actually looking for something that looks similar to a certain shape, like a triangular shaped orange thing. But
well, like I say, doesn't mean there aren't triangular shaped things out there that might trigger it. You know what I mean?
Oh, so, yeah.
So I don't think anybody has a single approach that's absolutely foolproof.
Probably not.
I think if somebody spent a lot of time training the model, I've seen enough success to know that, if I had probably 1,000 images, which by the way is like gag me with a spoon type of collection problem. But once you started doing that and trying to get one that covers your whole base without being biased towards one area, it's just, I'm sure that approach could be really good. So I'm still pursuing that.
Yeah. Yeah, I know this, if the cone's in front of it, it seems to find it pretty good. The other, I could really take the brute force approach, and of course it just takes more time. I could scan, say, okay, there's the scan for that one, rotate 180 degrees, scan again, and say, oh, this is a much better scan. I like this one. That's where the cone is, kind of thing.
Well, you should have distance, whatever your distance, your obstacle avoidance sensor or whatever. Well, maybe not your obstacle avoidance, but somewhere you've got a sensor that's, if you say you've got one in that direction, if you move towards it, you should get a pickup on your distance sensor saying,
yep.
Hey, there's definitely something here.
Something out there, yeah.
One of the things that I'm a little concerned about is if I get really, really close, so that orange is like, or the cone is like 80% of the image,
Yep.
I might have problem for it to actually say it's a cone, but I might. So for me, somewhere along the line, I'm going to say, that's the cone. My sensor says it's 6 feet or 6, whatever. I'm going for it.
Yeah.
And
Yep.
yeah.
Yeah, I haven't even put the LiDAR light on it yet. So I was trying to do it, strictly with the sensor, but that's probably a better idea. Maybe I should stick it on there and see what I can do with it.
Mm.
So, because I mean, that LiDAR light I think is good for, I think it was 40 meters or something like
Yeah,
that. Right?
it's a good distance.
Yeah.
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 Yeah, that might be too much. Otherwise, you might say you got something 37 meters away, and you go like, "Holy mackerel, that could be anything." You know what I mean?
Yeah. Let's hope it's not the gun.
Yeah.
Yep. Anyway, so that's where I'm at.
Cool. Looks like I think let's see, it must be at 5 weeks. I think we got 5 weeks. No, today's the 6th, so it's the 12th, so we're 4 weeks. We're 4 weeks away.
Closing in.
Yeah.
Cool. Well, cranking along. Looking good. So with that in mind, I think Michael, you said a super short one, but something.
Yeah, but I've talked about this before, but I'm going to bring it back up because now I'm going to start working on it. But remember during the competition we did the 4 corners, and I used this robot, which is a Polulu. Is that how you say that? Polulu or whatever?
Hallelujah. Yeah.
Yeah,
Okay.
and it has these thin wheels on it, which it actually, I got it to run a straight line. Well, with that code that I used, I couldn't get one of these cheap ones to go in a straight line, but it was the same code. So I blamed it on these wheels. Right. So my next adventure is to make an adapter, 3D print an adapter that'll fit this shaft configuration with these little wheels here. And because I'd like to see how well these kind of motors work with an encoder.
Yeah.
So
You can, Mike, those will go, those motors, you should be able to go in a straight line without any major problem.
Okay, so I'm going to try to do it with these wheels this night. So I'm going to try, and I've told you about this challenge before. I'm going to challenge myself to try to write my own straight line. It might not be a PID, but it's gonna use an encoder to. I'm going to try to write code that'll drive a straight line, my own code, instead of just copy and pasting. So anyway, I'm started that. I started that project today. So let's, wish me luck on that. So
one thing that I would, if you decide you don't want to go that route, I'm not saying that that's a bad route. I'm just saying is there's a DF Robot sells a really nice wheel that Dave Ackley introduced me to that fits on those yellow motors. Do you got one around, Dave? Somewhere?
It's a thin wheel like this.
Yeah, he's going to bring one up, I think. Okay, so
Okay, I looked at those today. So you kind of like them, huh?
Yeah.
Well, I might do it that way. Absolutely.
Yeah.
But I'm kind of curious on how a 3D printed hub that I designed myself might work. See how well it works. Just for the heck of it, right?
Yeah.
Just for the challenge.
But
yeah, I actually looked at those wheels today. So you like them?
Yeah.
Well, they're better from 2 standpoints. One is that they're a bit narrower. The other is that they're more rubbery instead of plasticky.
Right, and these are plasticky.
Yeah.
And they're all wobbly, and they're not very accurate rolling. All right, then I had another thing I want to run back by you guys. I'm gonna do. I was thinking about doing getting involved in that outdoor one next year. But I've been looking at these tracks. Let me see if I can't do a present now entire screen. Okay. All right, I'm fixing to go. All right, y'all see that?
Yeah.
That track? That's the guy's doing. He 3D printed all that, even the gears. And I was wondering. My question is, that's just it's an Arduino run with an Arduino. He's also got he also has some GPS on there that will run with GPS. So I'm going to take it off the presentation. Y'all get the idea. So my question is, what's y'all's input on using a robot like that for that outdoor competition? Is it doable?
My opinion is yes. Yeah, I don't see why not. Tends to be slower, but there's nothing in the rules that should cause you to have any problems with that.
Nobody's ever tried that before?
Well, I'm sure somebody's tried it. I just, I can't remember offhand any.
The biggest problem with the tank thing would be its height. So it has to be large enough to get through whatever. But as for a tank concept, yeah, I want to say Steve did it one year or somebody like that.
You're right. Steve did try it. He had one of I'm sure you can still buy them. It was, it has metal track wheels. Metal tracks. And it's a kit. It's about this big.
Yeah.
And I want to say it was about $200 or something like that. And that
There's only one reason why I want to do that is because I think it looks cool. So
We've done tracked robots before, and they work fine. What you'll find is that they can get a little tangled up in the runners and grass where the tank treads split. I've had another team that we were competing against who got really enthusiastic with 3D printing one year, and they printed their entire robot, and it was a tank drive robot. Think of tank treads as a whole bunch of individual points of failure. You need to be sure that they are going to they will survive the stresses you put on them, and
Right.
you're putting on bigger stresses on them than you would on wheels. The main reason to go for a tank is if you're in snow, like in that video, or on sand, or you've got terrain that is going to be hard to get over any other way, then it certainly makes sense. But in the kinds of environments that we go in Robo Columbus, it's probably not super necessary if you're already using like balloon tires or something like that. So it's just a matter of choosing what's appropriate, but do realize that they can be hard to maintain, and they're certainly, if they're made out of plastic, and certainly if they're 3D printed, even more so. It's, it's probably not going to be super reliable.
Kind of like one of my ex-girlfriends, eye maintenance.
Yeah.
Sounds
Okay, that's why.
Sounds more like an ex-wife high maintenance.
Yeah.
Or my dog.
Yeah, well, we're not going back to tank drive anytime soon. I can tell you that.
Oh, cool.
Well, that's why I ran that by y'all, see what y'all thought before I got too involved in it. So appreciate it.
Well, now we'll know if you're glutton for punishment because you want to do it anyhow, being obstinate, or if you're gonna.
I kind of like that. I like when people tell me I can't do something. So
As a potential future competitor, I say go for it.
I say, Michael, if you do that, maybe I'll do the hovercraft, but But then when I started
There
looking
you
more
go.
seriously at hovercraft, I realized, well, you don't see very many of them around. So
Could be a reason. Yeah.
they look fun. I bet they're a blast to drive, but oh my goodness.
I bet they're used.
Hovercraft are a childhood fantasy of mine. I wanted to build one since I was like 12.
You
Something
know,
like that. Yeah.
Do I,
now
do
it
I
just
hear a club
steals all the
hovercraft
fun.
project in the works?
Say what?
Do I hear a club hovercraft project in the works?
It could be. But the trouble is that
They
all the
drift
fun
like
is-
crazy. Yeah.
Yeah.
all the steam is that bubbles burst because now you can just go buy a hover bike that has the ducted fan drive and ride it. Soon it'll be FAA approved. I mean, where's the fun in that?
I thought the sticker price on those was like $500,000 or something like that.
It'll come down.
Oh yeah, mass manufacturing.
Personally rideable drones would be like a 10, down to probably 10,000 in a couple of years.
Yeah, and then you can put on your Star Wars outfit and go through the woods. Chase the Ewoks and whatnot. Alrighty. I think next we had in line, Michael. Anything else though?
No, I'm good. I'm good.
All right. So, Mr. Doug, what you got?
Okay, well, let me see. I think I'll start this off with just the progress on the robot, but I got a bunch of stuff to talk about. So let me, that's not it. Give me a second. Oh, shoot. I'm just going to do this. All right. Okay. Let's see. We got stuff hanging around. Okay. I don't know why I've got two cords. All right. So from last week, I've put on a mini wake, working on a prototype bumper. Still got a ways to go. I cleaned up all of the wiring. I made a decision to go with the Teensy instead of the Mega. So the Teensy's in here. You see, I've got all my I-squareds. The reason that I did that, what finally drove it to me in my mind, was the BNO 055 done by Adafruit is done the way they ought to do it. It has a built-in level shifter. So what actually gets to the chip doesn't really depend on what's on the I2C bus from a voltage point of view. But this fairly expensive, how do they say GNSS? GPS? What do they call a GNSS? What's the right word, guys?
Is it GLONASS?
Gloss. Okay, well, the gloss, I guess that's instead of a GPS, it's a gloss unit. Well, it doesn't have level shifters.
Yeah.
So you got to run it at 3.3 volts. That's it.
Yep.
So, and then I had, there's 1/3. What's this?
And it's expensive if you don't.
Yeah, that is right. You do that, it's very quick. So you also have to make sure your wiring is good. So what I did is everything on here is 3.3 volts. There's no 5 volts anymore on this, except for the servos. The servos will be 5 volts, but that's on a different bus. So should be pretty good. See, let's see how this works. Oh, and so anyway, that's where we're going. And I owe some from my discussion last week. I got an email from a gentleman in Fredericksburg, Virginia, who watches our weekly video occasionally, and his name is just James Westhoff, or Westhoff, I guess. and he pointed out some products and some tutorials. So I'm going to go first. We'll look at the tutorials because I think these are pretty good, and I'll put these in the chat. But the first one is from Hackaday, and it really discusses the items we talked about last week about there being a low pass filter that causes the leading edge of the signal to degrade. So that's and it talks about how you can adjust it with, we also talked about how you could change that a little bit with pull-up resistors. Here they kind of give you a little visual so you can see how using a stronger pull-up can help that problem. And then he also sent an inner one on differential I squared C, which is sort of what, when I showed the cable, how the cable was, see if they show it here in this one. No, they don't. But here you can see he's using a flat ribbon cable, which we talked about, as opposed to twisted pair.
Hey, am I missing something? I can't see anything.
Doug, did you mean to be showing? We've only
Oh.
seen you for the whole discussion.
Well, that sucks. Give me a second here.
Sorry.
Okay.
And if you
Here we
hadn't,
go.
who knows how long it would have gone on if you didn't speak up, Ted. I mean,
We were with you. We were in sync. Ted's
Okay.
failing the day here.
Yeah. So anyway, okay. So here was the one I was talking about. This is taking the leap off the board, interconnection to I squared C over long wires. And like I said, it talks about the degradation due to a low pass filter that gets formed with wire capacitance and pull-up resistors. And then it shows how you can change the pull-up resistor to improve the situation a little bit. Are you guys hearing this still?
yes.
I can't see anything when I'm doing this.
Yep.
All right. So anyway, this looked like this is the one I was saying. So one of the solutions is the one that I mentioned last time. I used their method of wiring, but I didn't use their two driver boards. Okay. But they use, one of the things that they can do is they use something where these driver boards are, they use a different one that breaks out your bus into differential signals. Otherwise, there's a plus signal and a minus signal. And this article here, it's called An Introduction to Differential I squared C. All right. And
Hey, Doug, when they say long cables, how long is long?
they're talking, I don't know about on this one, but they're talking generally 100 feet.
Ooh, that is long.
Yeah. So he's using a flat ribbon, which I'm not using. So anyway, it turns out James also pointed out, if you want a differential, a differential signal between your wires, there's a SparkFun module. I think you need at least two of them. You need one from the beginning, one makes it differential and one that takes it from differential and makes it normal again. And see this type of, I think they're called RJ45 connectors. That's the way I wish that I had done mine. And it turned out I actually had a couple of punch down female connectors in my box of networking tools and stuff. I could have done this, but I didn't. I did it the hard way. But that's life. But if I did it again, I would actually make a patch cable that was the right length and put these on the end. And I would continue, if you remember when we talked about the Adafruit method. It's a different, this one, like I say, this is another one, and this is, so I'm not sure. It says it works in tandem with the endpoint. So I don't know if you need two of these or exactly how this is set up. I haven't read the differentials, but I saw the 2250 price and I said, and then I have to have another one. It's 11, it's 30 something dollars. And then I just went to this guy, which they sell this. This is a different technique. This is an extender. It's an active terminator. So I think what you can think of this guy as is something that tunes your pull-up resistor. Okay, so it's a different approach than actually creating a differential signal to get you some more noise margin. So anyway, and they, this is, again, you can see here's a degraded signal, and then you can see they put it in and it looks like that. Okay, and this is actually only $7.50, but you have to pay $5 to get it shipped to you. So it's actually cheaper to, if you're going to buy one, probably to buy one from Amazon. But if you're going to buy more than one and you don't mind what coming US postal, then, buy them straight from Adafruit. All right, now Adafruit also has a tutorial that's really cool. Let's see, let me think. Okay, this is working with I²2 voice. They have overview terminology. They talk about clock stretching if you're not familiar with that problem, and explains how to handle it. And it talks about how the Raspberry Pi has some issues with it and a few other things. So it's definitely worth looking at. And they also talk about repeated starts, which is another thing that some I²² sensors use. If they don't have a response in a certain time, they just send another start. And some of the issues with that, they talk about pull-up resistor. I mean, this is Adafruit really did a good job. Okay, so this is definitely a thing to do. So we've looked at 3 tutorials and 2 solutions, one from SparkFun and one from Adafruit. And so now,
are you going over that long of a distance though? Are you already having issues with?
Well, okay, that was a good question, right? And my typical random wiring techniques tend to
mess with the rat, you mean?
Yeah, so that maybe might have caused problems, but I followed that so I have 4 twisted pairs in a network cable. 1 pair goes to VCC, 1 pair goes to ground, and then for the data line, the other part of the twisted pair goes to VCC, and for the clock, the other line goes to ground. And let me see if I can find this. Give me a second here. Okay. All right. So okay, here's what my signal looked like. Come on. So you can see I did have some degradation, but I don't think it was really bad. Okay. I feel that I probably could have done okay with it. This is the longest run with the motor running. Okay. So the motor is running and I'm not picking much up from the motor. And so that looks pretty good. So I think that would have been good enough, but just for the sake of argument, where is it?
What condition was that again, Doug? That waveform?
Okay, this stands for long wire with motor. So this is the long run with the motor running. Okay.
At the end of the motor or the end of the source?
Uh,
Or the source of determination on I squared C, right?
yeah, I did both ends. Okay, so here you see it with the UBEC. So the other one I was actually running on VCC. Here I'm running it on the UBEC from the sensor end. So this is up on the staff. Okay. All right.
Nice.
And
Missed.
this is with the motor with the UBEC down by the processor. Okay, so I didn't.
What pull-up resistor were you using?
I'm sorry.
What pull-up resistor were you using?
Whatever was on the give me a second here. The BNO 055. This is only hooked up to the BNO 055 because I was just looking at the long run. Okay. Now I was going to show you some pictures for the whole bus, but I haven't. I've got it hooked up, but I haven't had the guts to actually turn it on yet and make sure nothing smokes. So I'll have that next week. But
So how long is long again on your long run?
It's somewhere between, I'd say it's about 2 feet.
Oh, okay. So about 60 centimeters.
Yeah.
Yeah, I guess.
Is that right?
Yeah.
Close. And is that, Doug, is
It's
that
probably between 2 and 3 feet. Okay.
twisted pair or just open wire?
No, this is the 95%. Otherwise, the only places that are not cable or not that are not network cable are the very ends, and I have twisted those pairs together. Okay.
Okay.
So
this is like your Cat 5 we were talking about last week?
yeah, yes, the 2 to 2.5 feet of cable is Cat 5. Okay, and it's unshielded Cat 5, so it's not. You can buy a Cat 5 that has a shield on it. This is not.
Okay.
See what else we have? No, nothing there.
Yeah, I don't know. I may be dramatically surprised here, but that's a 400 centimeter one, and this is a 200 centimeter one.
Okay. Well,
from
here.
Adafruit.
So what this is?
That's very long.
See this?
Yep.
This is with the Adafruit driver active terminator or whatever it's called.
Oh,
So
okay.
sharp. Look at that.
Yeah. So this is, and I put the driver on the end. Otherwise, the BNO 055 module has two quick
Connectors on it,
connectors.
yeah.
Yeah. So this was very easy. I just stuck it into the end, the other quick tube connector, and it's just up there. So
So did you connect it with like one of these real short ones, the 50s or
50s.
50
Well, yeah, it was just whatever.
millimeter? That's one of the
Uh,
quick connectors.
Yeah. Give me a second. I'll just show you. Let's see here. Okay. Can you guys see my camera? You're looking at
Yes.
me right now. Okay. All right. So open that window. And
Or pin it.
yeah, so you can see here, here's what it, do you see what I'm showing? So this is the IC squared active, whatever, terminator. This is the little quick cable that goes between it. You can see it's been twisted, goes into here. This is the BNO 055. It's twisted into 2 pairs, but not very loosely. And you can see where I was hooking up the oscilloscope early. And then that goes into my into my Cat 5. The Cat 5 goes all the way down here underneath the frame, all the way over, and comes out. It's just underneath the deck over here. And then this is, you can see I've twisted these pairs, and then these will go over here, and then these guys go over to here. So, all right. So does that help any?
Mhm.
And then let's see. I think I've got one.
I got a couple of comments on your
Okay.
graphs here. If you notice on like this one here, you've got some rise time, but if you look at your switching, your negative switching, because I squared C bus
Yeah.
is a open collector setup, right? So any
Yeah.
ties are going to be generated by the pull-ups that are on that bus.
Mhm.
And typically what you want to see when the when the line is being driven, you want a heavy enough pull up that you see some ringing there at the bottom of that switch. You notice there's no ringing or no
You mean
over
here?
at the bottom there. Now if you go to your graph with your terminator board,
Yes.
notice there's just a hair of ringing right there.
Yeah.
That's really what you want to see.
Mm-hmm.
That's when I'm designing something, especially I squared C,
Mm-hmm.
I'll bump up the pull-ups until I see a little bit of ringing. And this, it can also be tuned based on the frequency you're running the I squared C bus. But you also have to remember I squared C is inter IC communications is what it stands for. It was meant to be, a device to device on board type of communication structure. It was never really intended to have some sort of transmission link. It's gotten really popular. So you have these little module boards that, like the BNO 55, it's better to move that away from where you've got your CPU.
Yeah.
So, I think what you're doing with the Terminator board, and obviously the switching times get a lot better. You still see you've got that disturbance right at the middle of the peak, and that needs to be at some frequency. But the way I squared C is sampled, as long as you're above a certain level, you're going to be okay.
Yeah, and they also, I believe, I squared C measures in the middle of the pulse.
Yeah. You can set the percentage, and in some processors, you can kind of move that back and forth.
Okay.
And it's for that skew or that roll. You don't want to sample it as it's rising, right?
Okay.
And again, that kind of boils down to what the frequency you're running it at. I mean, I can't see your time base on your graph, but it looks like you're running at a fairly slow baud rate here.
Yeah, I think it's whatever their standard one is, and I think it's probably 100K.
Yeah.
Okay, because this is 2 microseconds is the horizontal.
Okay. Yeah, and usually,
So
I don't know, I'd have to look up that carrier board, with that BNO 55, but typically I come out to about a 3.3, between 4.7 and 3.3K on something like that.
Mm-hmm.
But with the lower voltage stuff, you were saying that everything on your system is 3.3.
Yeah.
A lot of times too, I see like level translators used on I squared C buses because a lot of them are 1.8 volts.
Yeah.
So that cleans things up a lot too. But what I've also seen is the fault is that you've got to have pull-ups on both sides of that level translator, not just on one.
Yeah. So, well, this is like I say, I'm still playing with it, but from a I don't want to screw with this too much type of perspective. For $11, I buy this board. I mean, that's shipped from Adafruit, and I stick it on the end, and I don't worry about it anymore.
Path of least resistance, right?
Yeah, I mean, it's like, So, but all that said, now that I've got I have the I squared C bus as I pictured it. Otherwise, all the I2C devices are now connected. I haven't actually turned it on because I'm still in the process of double checking the wiring to make sure I don't screw it up and blow things.
Are you using a single I2C bus for all your devices?
Yes, that's what I've got. So
That's the one straight out of the Pi, I guess.
no, this one is, I'm not, I backed away from that. I should have mentioned that.
It's the teensy.
It's a teensy. So the teensy, I think it's I want to say it's an M0, but I don't, it might be an M3. I'm not sure exactly which one it is. So it's a NXP, if I remember right, or it might be Espresso. Well, I don't remember, but it's some sort of ARM chip. So because of this,
that doesn't really make any difference to the what the
Yeah.
signal's going to look like or who's
No.
driving it. But
yeah, well, because of the problems with pulse stretching on the Raspberry Pi, and the fact that I was concerned about having all of the devices hooked up to the Raspberry Pi. It's just easier for me to do everything and just use because the only thing I needed the Raspberry Pi for was the AI, was the running the image object recognition program. So all it's going to do is communicate by, it's just going to send to the teensy, turn left, turn right, based on where it's seen cones. Does that make sense?
Yeah.
So, I could have easily, said, okay, put everything on a Raspberry Pi. And I think that would work. It's not, but I'm more comfortable putting everything on the teensy. I went through all of all of the libraries that I was going to need for all my I2C sensors, and ensured that yes, verily they do work on the teensy. So everything works individually. So I've tried each module individually on the teensy and demonstrated, yeah, this one works, this one works, this one works. Now I've got the bus line all set up. I haven't run that test program yet. We're going to find out. And, but that's the plan right now. One thing that I've got to figure out is on my GNSS unit or GPS, I want to go to uBlock and customize the messages that are sent down so that it's just what I need. So I don't end up banging the bus with stuff that I don't need. So the approach that I see in the libraries is they're pretty much just, what is it, NMEA? What's the name?
NEMA. Yeah.
NEMA. They're just NEMA parsers. So they go in and look for the message ID and then parse that screen, and you tell them which ones you want to parse, and the rest of them it just throws away. Well, I don't want to be banging the bus with that, so I want to go ahead and customize the GPS unit to only have the ones that I need. And it's pretty much latitude, longitude, number of satellites, fix. I think that's probably all I need.
it's not too dissimilar to what I do,
Yeah.
except for I basically just boot the thing up and it runs at what it's configured at. And then if I see a message that I don't want to get, I just shut it down, because along with subscribing to a message, you can turn a message off.
Mm.
So I just track from, if I see a message I'm not interested in, I just shut it off. That way I don't have to worry about, shutting it down ahead of time. Because I've gone through a couple of different GPS radios and used the same software. I kind of extended it, say, okay, well, I need to shut it. I'm getting this message now, so I'll shut that down.
Yeah.
So that's kind of the way I handled that.
Well, like I say, I'm gonna kind of follow. Probably initially, I'll probably just follow what pretty much the demonstration programs from the different vendors to start with. But if I can't get all the messages through, well, might have to do something about that. So like I say,
email messengers are definitely the way to go, because like I said, I've had the U-blots, I've had maybe half a dozen different GPS radios. I had an old Lynx one originally, and like I said, I've used the same code on all of them.
Yeah. Yeah.
It's definitely pretty much a standard that you'll run into.
Well, I think that that I'm not going to, okay, in U-bot, you can do a lot of weird things. Okay. Yeah. But what I want to do is, one of the things you can do is you can just select the messages you want to send. That's pretty low level, I believe. I mean, that's not as going in and saying, I just want this register or that register. You can just say, I want this message, boop, and you won't, because I think by default it sends about 10 messages. And so I'm not going to be trying to change the format of the message. I'm still going to use a parser. And I think that's what you're really saying.
Yeah, well, you have different message types, right? Different message headers.
Yeah.
And there's, like, especially the GPS, the latitude, longitude, it comes through in several different messages. There's like an enhanced message, and then there's, the standard message, and they all have a different tag that they are identified with.
Yeah.
And, they've got a different data structure, and because they're all really just text strings, right? So in the serial stream, it's just text data that's being passed across. So when you capture that packet of data, then you can process it as a string.
Yeah.
But like I said, it's inherent that you can either enable or disable the messages. I don't remember. That protocol is documented really well. So you can always look up, how you subscribe to a message, how you shut a message down. I think some messages you can even set the frequency that you want them. You like some of I think the U-blots, you can actually set up alerts. I looked at that, because you can set up alert when you hit, a condition like a GPS coordinate or whatever. But, it just didn't make sense to do that external and then, still have your software trying to figure out where you're at and where you're going to go.
Yeah. Yeah. So anyway, I've made a lot of progress on the actual physical robot, I guess is what I would say. The one last part that I'm still working on is adding an encoder to the drive shaft. And I've actually got the part printed, and unfortunately, it's one of those things you got to tear the whole robot apart again to get to it. But essentially, I'm replacing this part in the robot, and there's a little space here where my little rodeo optical encoder just drops right into here. So this sits right on the robot, and the shaft turns around underneath. So that's the last sensor that I need to add. If I get that guy added, then the robot's built. And like I say, I've tested out each one of the modules individually. So now let's start putting together. I'm hoping next week we can see it drive at a cone. Yeah. Actually, the biggest problem I seem to be having right now is I created this is a bumper that I put together, and it turns out it's taking more tuning than I thought it was going to take. We'll see, but I might not have a good bumper yet, so we'll see how that works. If that works, then everything will be functional. Now it's just coding. So let's see. Was there anything else I wanted to share? I think that's pretty much it. I went through the ice card stuff, and I wanted to make like I say, a shout out for James Westhoff for him sending me that message and letting me know about that other information. So I think that's it.
At least his name wasn't Jack Me Off or something.
Yeah.
Right.
Yeah.
There's an Austin Powers moment. Okay.
Yeah.
All right. So thank you, Doug. So Mr. Scott, moving on that note.
Yes.
There's a send up for you.
Yeah, well, I've got here, let me see if I can share this here. So I finally got some field trials done. You see that?
Yep.
So unfortunately, this is all just remote control, but at least the chassis running. I finally got the communications working right. This video is very interesting because when it's at full speed, the wheels look like they're stopped. If you watch it, look, it looks like it's skidding, but it's really not. And I think that's the frame rate versus the wheel speed, but I think that kind of gives it a weird look to it. So like I said, I've got my camera mounted now. I built a little box around it so it doesn't get, torn off or damaged. I'm just going with the Pixie because that was the path of least resistance. And, I have that code and it's already working. So, it was go with what you have because I only got 4 more weeks to mess with this. So, but it's, I'm slowly getting the gremlins out of it. So hopefully it'll do well. That's hope.
Cool. That's a nice looking. Yeah, it's a nice looking robot, Scott.
Here, I'll tell you what. Let me
Are you going to keep it open, or are you going to make some fancy schmancy looking shelf for it?
I'm going to have to put a cover on it because when I was running it in the yard the other day, it got grass all in it. So I'm going to have to make like a cover for it. But
mine makes an excellent grass catcher. So.
Yeah, it does. So that's kind of the guts of it. It's gotten to be, I think, overly complicated now. I mean, because Doug, I'm doing most of my processing on the Pi. I've got an interface micro that is only responsible for generating the CAN messages, which go out to the drives.
Mm-hmm.
And I've shown my USB to 4 serial port chip. I included that on this board. And that's when I'm running all my serial buses, like to my LiDAR and to the GPS. The AHRS comes through there. And then the communications from the CAN bus comes through that serial port too. So trying to get some of the Pi stuff set up so that, the application starts on its own and all that kind of, convenient stuff.
I don't know if did you see John's little board? He actually offered it. John, I'm making an offer for you. That I think he was going to give it out. That's the one that it's right here. Did you see this?
Yeah.
That one, he has 2 boards here. When it starts up, you have these 2 switches here. And when they're activated, it will run a script as a service in the beginning. So you can get your pi in the position that you want it to be with one of these switches. And in one of these other switches, you can either kill that service or not, or you can do a nice headless stop by pushing a button and it'll shut it down. A really nice little board. And it's got indicators, which are always helpful. So
What-
anyway,
Is that a particular overlay, or how are you controlling that? You know, the script. I mean, is that using System D or what?
Yeah.
I'd let John go through the
It's
details.
just a system D service that launches the script that launches your application when a button is pressed. So when it first comes up, when your Pi first comes up, the service runs, that green LED flashes. Then when you want to start your application, you press the button on the edge of the board and it starts your application. And if your application starts successfully, the yellow LED will start flashing in addition to the green. And then if you want to shut your application down, you press that button on the edge a second time and it'll shut down. It'll kill the process for your script.
You know, I was just working on exactly that, because I have some dip switches here which tie directly into GPIO on the Pi, and then I have a push button which I enabled the DT overlay shutdown pin. But what I wanted to do is exactly what you're talking about, where I can shut down the application, because when I'm developing and when I'm debugging, I SSH into it, and I basically use GDB to transfer files and to debug on it. So it would be nice to be able to just boot the thing up, have the application come up if I'm going to debug it, or I need to shut the application down. So this would give me an avenue to do that. Would you be willing to share that script with me, John?
Sure. I put it up on GitHub. I'll put it in the chat here momentarily.
Okay. I'm not going to have the cool LEDs you got, but.
Well, as long as you got a switch to control it, a GPIO to control it.
Yeah. Well, my original intent was to use the button as like an input button, and then you can read the address of the switches to run different courses, which is what I do like with CanMan. And I had a similar setup on Burp, where you would select a number and then you would hit the button and you could activate a particular course or, whatever, because it would sample that dip switch settings when you hit the button.
Yeah. So there's the link in chat.
Okay.
For the script. If you got any questions, you can always send me an email.
Okay. Appreciate it. So this is the run headless SH, I take it? And run headless service. Yeah, okay. All right. Thanks, John. I appreciate it.
And I was offering in a limited supply, these boards free to anybody in the club who wanted one. I just got several of them here that I haven't populated yet.
Can you share the schematic of that with me, and I can basically just mimic, because I should have the hardware I need here, and I've already consumed, there's a ribbon cable on from the Pi to the interface board. So, picking up individual pins at this point, would be a difficult thing, but.
Yeah, well, the schematic, KiCad schematic is on that GitHub site as well.
Okay. Yeah, I see it. All right, thanks. That's
Very cool.
That's all I was going to show.
Well, that's good progress. Is there some kind of star for that video? I've lost track of our scheme.
I don't know. Where's David with his gold star?
Well, since it was RC but
Yeah.
it's definitely a black star.
There we go.
Oh man, y'all
There
are
we
such
go.
a tough crowd here, man.
This,
We have very
I'm-
high
I'm-
standards.
You know,
in
I'm
this
not going to feel bad at all when I beat you, Doug.
Yeah, well,
Ooh,
you should be worried about Ray too. So
I won't feel bad when I beat him either. I've been there.
probably not. Yeah, but you already tipped your hand. You said you weren't going to be participating, right?
oh, he's
Well,
over
y'all
there.
moved the contest,
Yeah.
we opened
right.
it up.
so I'm coming for you.
Invitation.
Yeah.
So you are going to participate then? I thought you said you
Yeah.
couldn't.
No, he's there.
Oh, he
No, I
is.
mean, yeah, because it was originally going to be what, next weekend or weekend after, something like that.
Yeah.
And then y'all moved it back. So, and that's why I'm scrambling now, because I'd kind of moved on to other projects. I figured I had a whole nother year to work on this. So that's
Oh,
one
okay.
reason why I went with my Pixie Cam, and I'm just, right now I'm just trying to get what I had working with Burp in here. And I've still got Turd up there, so that's the defending champion right now.
So this will be good. So if it helps, I don't know who to outfit with the orange cone shoes, but maybe we can supply all sides and just see what happens.
Well, I think too, Scott, if you got more than one working robot, go for it, bring it. More competitors, the better.
Well,
I mean,
I
love to see
literally,
it.
yeah, the Turd has literally not done anything but collect dust since last year.
Yeah.
And that's probably will be the case until I pull it down and charge the battery and say, will you work?
Yeah.
And even though it's only been sitting on the shelf, we all know that, those gremlins come in at night.
Yeah,
Is
that's
there-
true too.
Is there a bonus prize for catching the person that's wearing the orange cone shoes?
Well,
Couldn't understand you. Sorry.
we have to see if how that fits into the point scoring system. Well, cool. All right.
Yeah, I was gonna say I tuned the bumper on mine. I actually tripped over it and broke it off and had to re-glue it back on. So I guess that's tuning, but
Nice.
Oh, the other thing I was playing around with was the polarizing
The filters.
lenses on.
Looks
Yeah,
like
the
you've
stick on
been cutting those up more and more ever since they first showed up at the makerspace.
Yeah.
Yeah.
Yeah. Anyway, so there's like an outer ring that I can twist to adjust the relative position of the two, and it seems to work pretty good as far as a polarizer.
Are you guys using Raspberry Pi 4s nowadays on your robots instead of 3s?
Probably Scott's the only one.
I think Scott said yeah.
I'm using a Raspberry Pi 4 on my Halloween skull face.
Well, like I say, I'm going to be using Raspberry 4, but I'm not as the primary. It's just going to be doing its own thing independently and sending information to my other processor. But
Is there a big
I
difference
think
between 3 and 4 as far as these robots go? As far as
yeah.
speed?
Oh yeah, the 4 is just phenomenal. Do you need a 4? Probably not.
Oh, I've got one. I've got one. I've never fired it up. I'm using, I've got 2 3D printers that I'm using an Octoprint with, and I'm using Raspberry Pi 3s on those.
Yeah.
That I fixed up years ago. And I've got a 4 laying around. I've never done anything, never had a reason to use it. So
The 4, when you're using it, if you're using it with a screen and a keyboard, it's just like a laptop. I mean, it's fast enough you probably don't even notice that it's just a board. Especially if you add an SSD to it.
Yeah, and as far as running Octopi, my MK3S printer, Prusa printer,
Yeah.
3D printer, I've got just a Pi Zero plugged into it. It's got a special slot on the side just for running headless with a Pi Zero. It runs fine.
Yeah.
Is Pi Zero, is that a 3 or is that a 4? Or
It's not even a 3. It's
a 0.
It's a stripped down Raspberry Pi.
Single core.
Single core.
But I mean, what's the speed? What's it compatible to as far as speed goes? Is it closer to a 3 or a 4 on speed? Processing power.
It's not even a 3.
It's like your toaster oven. It's a single core. I mean, it's the Arduino of Raspberry Pis. Let's put it that way.
Okay.
Well, there's a Pi Zero, a Pi Zero, and a Pi Zero 2, and the Pi Zero 2 has a faster processor.
Yeah, it's like a 3.
Yeah.
A single core. I think is it single or dual core, the 2?
Pretty sure
I thought it
it's
was a quad core.
Well, yeah, I think it's single core.
Single core.
Is it single core?
Not sure. I'm not sure.
Yeah.
I thought it was a quad core.
It'd be, like I say, if you were buying a new one, you'd always buy the 2. I've got they used to give away zeros at Micro Center pretty much. A couple of bucks, I think it were $2. Every time I went in there, I'd buy one, even if I didn't need it. So, and, this thing that was put out by, I think it was Intel or Google, I can't remember who, this little box, do you remember these?
Mm-hmm.
It has a Pi Zero in it.
The Google.
It's
Well,
a Google.
let's
Yeah.
be clear. It was a Google Vision AI. And it has a Pi Zero, but it's connected to a Movidius bonnet.
Yeah.
So.
Yeah, the Movidius is doing all the work.
Oh my goodness! Yeah.
It's a 1 gigahertz single core CPU. The Pi Zero, just the regular Pi Zero.
What about the Pi Zero 2?
Let's see if I can pull that out.
Quad core.
The 2 is a 64-bit quad core system on a chip.
So it's a significant boost.
Yep.
But what's its memory though? I thought there was people were whining about the memory, I believe, on it. Is it 1 gig or is it half a gig?
I thought it was a half a gig.
Let's see. 512 meg of RAM.
Yeah.
Half a gig.
Half a gig. Yeah. That was the thing that people were whining about.
I guess I got to buy 3 if they want, more memory.
Yeah.
Well, I mean, at one point, like you said, Micro Center was virtually giving them away. You can get them for as little as $14. I think at one point they had a special. You get one for $10. I think it was insanely cheap.
Mm-hmm.
But you get what you pay for.
Yeah. But for a lot of jobs,
with like 4 gig cost, is it over like $55 or something?
Yeah, I think
a 4 with 4 gig.
Yeah, if you could get one.
If you can find one.
Yeah, I'm on the Facebook Raspberry Pi forum, and there are people constantly complaining they cannot get a Pi 4 right now or a compute module.
Yeah.
The supply chain has not eased up at all.
Yeah.
Our RPI locator shows a compute module, CM4 modules in stock.
At what price?
Oh, well, that's a different story.
Well, actually, Micro Center had out 10 of those little computer board ones. So they were equivalent to a 2 gig 4, and they were selling them for $66, not even $99. They were selling them for $66.
You talking about the Raspberry Pi 400?
Yeah,
with the keyboard?
Yep, but they didn't last very long.
Oh, Yeah.
Yeah. They did show up.
I'm sure you could find a 8 gig Pi 4 on eBay for over $200.
Yeah, probably.
Yep.
Oh well. I'm just glad that before all of this hit, I went ahead when they first came out. I went ahead and bought two, and that was a smart move.
I bought one back in the spring, a Pi 4 gig, and I think I spent $140 Canadian on it.
Oh wow.
Normally they're about $100.
Yeah.
And I said, well, they've got them. I'll buy it.
Mm-hmm. Yeah. Well.
Well, Doug, I wish I found out about that active terminator. I just bought a bunch of cables from Adafruit, and I was going to use one of the 400 millimeter and a 200 millimeter to go between the SparkFun GPS module, the B&O 055, and the color sensor. So I don't know if that's going to cause me problems, because that's just at about 2 feet. Well, no, 24 inches, I think.
Yeah, like I say,
Well, 2 feet. Yeah.
They have them in stock. They're not that hard. I mean, like I say, if you want it tomorrow, you can just buy it, pay $12
Yeah.
from Amazon and get it now. And they say, well, they're only $7.50, but they're $7.50 plus $6 for shipping.
Shipping, yep.
So they're $12. So I think I figured you paid 80 cents or something like that. It was worth it just to buy them off of Amazon.
Yeah. I thought the neat pre-made cables may get rid of part of the rat's nesting problem. So.
Oh yeah, I think they're a big help. Well, yeah. I mean, that's like I say. We'll see how it all goes when I turn the power on, and they're all, like I say, the I2C bus is made. So now I just need to check the wiring one more time. I don't want to do anything. I really don't want to lose that GPS unit. That's $74. So plus you'd have to get one. Yeah.
What do you got there,
There's my 4 that I've never used. I'm gonna have to figure out something to do with it.
Are you taking bids?
I didn't realize how expensive they are now. I just looked at the price on Amazon. It's outrageous.
It's like Twitter stock, you got
something. I could just sell this for about $300. I'm just kidding.
Is that a metal case you had there?
Yeah, it came with it. One of them. Yeah, it's a metal case. It's one of them kits. You buy one of them kits,
Yeah, be aware that if you're using a metal case on your Pi, it'll definitely affect your Wi-Fi signal if you're using Wi-Fi.
Okay. Like I said,
I had a problem with that. I wasn't even using a metal case. I bought this for my Pi Zero 2W. I bought a metal heatsink that covers the top of the board, and when I put that on there, my Wi-Fi performance went to hell. So
wow. I think I put ROMs, game ROMs on here one time for my granddaughter. That's why I think I bought this. I had a lot of retro games on this thing, if I remember right now.
He could probably resell it right now for a profit.
Probably right.
Hey, Scott, on your Raspberry Pi, did you incorporate some sort of light sensor to change the amount of light that your Pixie Cam is exposed to, or?
No, not on this one.
Oh, no.
This is one of the Pixie Cam 2s, and they're supposed to have better contrast and better, adjusting, the light balance.
Yeah.
So we're going to give it a try. I did make the box a little bit, deeper so that it has a little bit of shadow.
Right.
You know, unless the sun's going to come in at it really kind of low. So,
Mm-hmm.
no, I played around with filters and all kinds of stuff on the Pixie One, and I never saw that it made a difference because it's the difference in light. You know, if you're in the shadow, it's one hue, and if you're in the
Right.
sun, it's a different one. And
Yeah.
it didn't matter whether you tuned it to detect it better in the sun or detect it better in the shade. You still had a problem detecting it in both environments.
Yeah. Yep.
That's why I was going to go with the object recognition like Doug's doing, to just eliminate, that coloring issue to start with.
Mm-hmm.
And, but like I said, I hadn't got there yet. So I just went with what I had, and we'll see how it does.
Mm-hmm.
We'll see how
Scott?
far I can get. It's
Scott, do you have a OD light? Did you ever end up
Yeah.
with?
I have played with it.
Okay, well, you can go to RoboFlow, and my database and everything is up, and models all up there if you want to just try it. So
Yeah. Well, at this stage, I'm just gonna stick with what I got, and that'll be next year.
I noticed Ed put in something in the chat. He said he got a BMAX. I think that's isn't that one of those little block PCs? Is that what that is, Ed?
Yes, that's correct.
Yeah. So are you using it on a robot or just as a small PC?
I haven't used it yet. I recently got it cleaning out a storage unit.
Huh.
They're relatively new. Apparently, they're about $169 at Amazon,
Yeah.
or maybe even a little less. And there was an external hard drive along with it. I haven't plugged it in, haven't fired it up yet. But they
Oh,
usually come with Windows 10 or Windows 11.
Okay. Well, that sounds like you got a really good find.
So we're going to see on a future episode of Storage Wars, or
A past episode, most likely. He's
Oh,
done
past
about
episode,
20 years of doing it.
Yeah.
so seriously, you
Excellent.
got a storage unit and it happened to have one in it, or
Yes, I recently got it. There was quite a bit of electronics. I was happy with it.
Yeah, it sounds like you got like I said, I don't know what you paid, but that probably took a lot of the, added a lot of value to whatever was in there. That's cool. Yeah.
I got a Pi related question. Has anybody ever used the one wire interface on the Raspberry Pi?
Yeah, I've used the temperature sensors, those DS,
Oh, yeah.
whatever they are.
Yeah, that's what I see most quoted. When you look at one wire interface, they almost always refer to the temperature sensor.
Yeah.
I was noting that the one wire interface in all the diagrams I've seen, they'll have about a 4.7K pull-up resistor or something on that order. There's one line for data, that one wire, and then typically the device takes power and ground. And then there's one wire for the.
No, it's what they refer to as a parasitic device. So it actually pulls power from the pull-up. Now, I don't remember that well, but I think there was an option where you could actually add, its own power where it wasn't parasitic. But the whole one wire thing, because you can run those off of just two wires. You got a ground and your data line. And like I said, it's parasitic to your pull-up on that line.
Yeah. Well, in the images I've seen for the devices that people are hooking up, and one of them is that DS temperature sensor, they've got three wires connected: VCC, ground, and the data line.
Yeah, I was gonna. Cause I've got some here that, yeah, they've got the three wires.
Yeah.
This is one of the temperature sensors. And I always ran it with power. I think the power is the red one. And then you like I said, you got a data line and then ground. But again, the data sheet shows that you can run it without that. I just never did. I had a lot of problems with the Pi crashing. What I was doing with it is I had a teaser, basically it's a little chest freezer that I had extended into like a kegerator, but I was using it for chill water for fermenting beer. So this thing was keeping the chill water cold, and then I had a pump running it through, and I was using the Pi to control the temperature of the keezer. And I actually lost a couple of batches of beer because what happened was the program, because it's a Python script, and it's just like everything else in Linux. You go out and you read a file and you pull the value from the file. And it would get into situations where the file was locked, and so it would just lock up, and it wouldn't run the compressor, so my chill water wasn't cold anymore. And
but it didn't just lock up the application. You're saying it actually crashed the Pi?
No, it would lock up the application.
Oh, okay.
The Pi was still running, and I thought that I had a noise issue, so I put a electronic starter on the motor. I put filter on the motor, on the compressor, and nothing really seemed to help. And it was overkill for what it was anyway. I mean, I had a little touch screen on it, and I had a little front end with little graphs, a little charts, or the little not pie charts, but little graph on there, temperature and all that. And like I said, I scrapped it all, and I put a $20 temperature sensor controller on it, and I never lost another batch of beer due to that anyway.
Did you have a little guy chugging a beer on the front of it?
Well, I must have brewed, I don't know, maybe 50 gallons of beer, and I only was able to drink about 15 of it. So I just never got over the learning curve, I guess. Some of it was equipment malfunction, and some of it was, inexperience. So, and that's a lot of hard work. I mean, if you're not cleaning something, you're scrubbing it. If you're not cleaning or scrubbing it, you're sanitizing it. Either that or you're watching the clock, and it's like, okay, now it's time to do this, and I got 5 minutes before I got to do that, and it's a lot of work. I really have a new respect for brewmasters. I think I've decided I'd just rather much drink it than make it.
Yeah, my brother tried to, I'm not certain, some sort of dark ale, and he even did stout, and his stout wasn't bad. He could have given Guinness a run for their money, I think, but they like to drink the black and tans.
I made one of the batches I did was successful at was a Dunkel, which is kind of a dark German style beer. I think with the darker beers, you got more leeway.
A little more flexibility.
Yeah.
Oh, they're all fun to drink anyhow.
Yeah. A lot more than brewing it, that's for sure.
Oh boy.
So in the meantime, I'll drag us back to the subject of tanks. So there's one I found that might be of interest if he wants to build print. So let me show you the window. So there's this out there. Okay, and it's interesting because the way the treads are built, to me at least. So they basically use a timing belt, and then they print the treads and then put them together. So that's a little interesting the way it's built. there's files. And then I'll get to
It's like a lot of
there.
3D printing.
Oh yeah, but it's well constructed 3D printed. It looks like because he has the blocks that knows they'll adjust the tension on there, so that's well built. And
I noticed he's using those motors I was looking at.
Yes, and they're using those motors that are relatively cheap that people like.
Yeah.
So that's why I say it looks like it's right up the alley for you.
How do you think he mounts the track cross to the belts?
It's
How do you think he mounts?
adjustable.
Huh?
Effectively, it's adjustable. On the top there, you'll notice that it has screws. So this part here can move based on the size of that.
Oh, you asked about the little pieces to the belts that make up the track.
Yeah, the little cross members on the timing
They're
belt.
3D printed.
I think he's got O-rings on the end that hold them together.
There's O-rings.
Oh, he made those timing belts.
Yeah,
I guess
now he buys the belt.
At TP. Oh, he did. But I wonder how he cuts that slot in it. That's what I'm kind of getting at.
Cuts the
That's
slot. It's probably
interesting.
3D printed. It looks like there's two halves there of those red pieces.
Okay, we'll pause a moment.
Yeah, it looks like it's two halves.
Hey,
Now,
you
it's
could probably.
two halves, and then there's these O-rings.
Oh.
And then on the print part, we'll back to the
Yeah,
top.
he uses O-rings to hold them
Right.
two pieces together.
Yeah.
Yeah.
And then see, there's the two part, and then the
Okay.
O-rings basically go right there, and then you see he has the lines and markings to align everything together.
That's
That's what I
cool.
said. That's pretty neat, well designed layout, functionally well built.
Could you share that URL of that on the?
I just put it in.
Okay.
Oh, cool.
I was gonna
Thank
say it
you.
should be on the
I
top
put in
there.
another link too that doesn't belong there, but I put in a link for this one.
So yeah. So as I said, it looks pretty well constructed and definitely a different design I have seen before. So
That's a pretty good one.
yeah, that's what I thought. That's why, yeah, because I've seen where they'll print out the whole belt, but you're limited by your printer size, and they don't adjust for tension. And yeah, there are variables that this has that I definitely like, even to being able to scale it up size-wise.
Well, the thing about, to me, it looks like that timing belt would be a lot more. It'd be pretty, take a lot of, pretty rigid. In other words, it'd take a lot of torture. That timing
Yeah.
belt.
Well, the main thing is that the gap is wide enough, and the way it's built on the reel, it won't get clogged as much, I think. But it's one of these things you'll just have to try it and see.
Well, actually, the concept too is just something you could build on. You could buy larger timing belts.
Yeah, that's why I said to me this looks well built for what it is.
Yeah, I suspect he's running on the O-rings for most of his traction.
Yeah.
Because I don't think those things, those 3D printed pieces that he uses.
Well,
Stop there. Yeah.
On what surface though? Right? If you're on a smooth floor, then it's going to be on the O-rings. But if you're in a softy, if you're in moss,
through grass,
you
you might.
The gap. That's why I said he has a decent gap, so I don't think you have the clog problem that you can run into when they're too close together. And if
it looks like.
And it looks like it'll drip well based on that right there.
Yeah. I like that a lot.
And then you'll notice how you get the motor. Oh, let's see, we have a good picture of that. Yeah, back. Okay. And notice how you'll get from, there for those motor and how it gets connected there into the real drive motor slot. So yeah, the fact that he has this built was another part of the design I like.
I like. When did you find this? Is this something you
Today.
just ran
I just found it today.
Thingiverse.
while we were talking?
Yeah, actually, well,
That's pretty good.
I was like, I hadn't seen this one before, so I was like, okay.
Yeah, I think
found
John
that
has a platinum
it's kind
membership.
of difficult to
on
find
Thingiverse.
anything good on Thingiverse because a lot of stuff out there is just junk.
Yeah, that's why I say you have to, but once and every so often there's things like this. It's one of those every
There's
so
that new
often.
there's that new site I heard. Who's that 3D printer company that's trying to kickstart their STL site? Who is that?
Don't
Oh,
know.
it's who's the guy who's the guy that makes the rip wraps? The real popular guy. Bruce. He's got a new site for STL files. I heard he's trying to get it going.
Yeah, I heard that too. Yeah.
So anyway, I like that, John. I'm gonna look into
I
that.
was going to say, if you're going to build one, hey, there's one that looks pretty
I
good.
don't. I enjoy 3D printing. I get a kick out of it. So I like creating stuff like that.
Yeah. Well, as I say, it looks like it has a couple key features, and one of them is being able to tighten the belt. The fact that you don't have all these little individual parts that has to hook together that come loose because of the way they use the O-rings to hold the thing together. I like that feature. So yeah, there's several parts to it that was well done.
You know, and I've got some old. When I originally was going to make my my original design for my claw machine was going to be, designed after like a 3D printer with the timing belt stuff, and I've got some of that timing belt material laying around that I might just pick up and start messing with. That 3D printer timing material. So
Pretty cool.
Nice.
John, thanks for roping us back into robot-y things.
Well, tank things, but as it's a main thing though is because as I said, Steve had one that tank 1 year, and I have a tank somewhere around here. And the biggest problem with tanks are you have to have the torque to get through the drives and whatnot. In other words, are ideal for sand, flat land. And then the other problem is the tread tends to get loose. So you have to have tension adjusters somehow to keep getting off the tracks and the links themselves. So but they can be interesting. They can be, fun.
or high maintenance.
Well, depending upon the design, how it's built. That too, how it's
I'm
built.
gonna look into that. I'm just for the fun of it.
Got a couple extra rolls of filament you want to burn up? No.
I've got some old filament I haven't opened up. That I've got some old filament that I've never opened it. I use some filament that's probably about 4 years old. I've been using it, and it's a wonder that stuff still prints. But
I've had issues. Like if I
it gets brittle.
Yeah, it'll actually if it sits there for too long, it'll actually like if it was curved coming off the spool, it'll actually break.
I know. Yeah, I have that. I have to go. Mine's out in the shed, out in my man shed, the space shuttle.
Space. Yeah.
So I go out there to start it up. It's already snapped. If it sits there for any amount of time, it's already broke.
Yeah, I've kind of experienced that. A little
But
disappointing.
I'm trying to use the stuff up because it costs money.
All right, guys. So let's see. Do we have any other items in queue?
It's a lot of work ahead to get a completely working, finely tuned machine.
4 more weeks. 4 more weeks.
Yep.
But it's sounding good for at least a handful of robots out there to roam around. So that'll be good.
And if not, Scott can blow the dust off of Turd, and
We can see what it's like to waking up after a
That's
long
right.
sit.
Hey, now you're talking about the defending champion here.
Basically.
Let's not forget that.
Or he's going to do it the way of the famous rock bands, where they have their big run in the 70s, and then when they end it, there's no more coming back, because it would only devalue the great run that they had. So, but when I bring duct tape and baling wire, there's no such concern. So I'm going to bring it. Okay, guys. Hey, well, if there's nothing else, I'm going to suggest that we give ourselves back the rest of the evening and go get some
Get to
robot
work,
parts
okay?
and build some robot things, and come back next week with some robot videos. With a whole big stack of gold stars. Okay, that sounds, I'm going to say it that way anyhow. Good night, guys.
There you
Take
go.
care.
We'll see you guys.